In the previous videos, we were working with evaluating algebraic expressions, and of course, this required us to simply plug in a number or substitute a number in for the given variable. In this particular video, in this part of the lesson, we're going to actually work on simplifying algebraic expressions. So our task is going to be more geared towards making the given expressions a smaller, kind of whittling it down, if you will, to a less of a term. So if we look at this, we first of all need to start by simply understanding what common terms are. So to simplify, we need to combine like terms. And so if we're looking at like terms, we're looking at things such as x plus 2x. Since they both have x to the first degree, and this is an understood 1, then we can simply add that to get 3x. So 3x would be the simplified value. And of course, in order for it to be a like term, the exponent needs to be the same. So if we had x squared plus x squared, we would get 2x squared. And again, that's because we were adding the understood 1's in front of each of these. This can also work with square roots. So if I had 2 times the square root of 3 plus 3 times the square root of 3, the square roots of 3 simply act as a combined term, so a like term, so we could simply add the 2 and the 3 to get 5, and then the square root of 3 acts just like the variable does. Now, if we had x plus 2x squared, there's nothing that we can do with that because the x and the x squared are not like terms. So the important part here in this part of the lesson is just to be able to identify which terms are like terms and which terms are not like terms. So let's take a look at a couple examples. So if we look at example number 4, we have a textbook way of looking at this, and the textbook way is they simply factored out the common x monomial and then added the two numbers together. This is not a necessary step. I'm not going to require you to do that. I think that you're aware enough that you can just simply add the 7x and the 4x and go straight into 11x. So if you want to take that route, that's preferable to you, that's the route you need to go. And so you can see in part B that we grouped the common terms together. So the n squareds were not next to each other, and so we grouped them so that we could get common terms. Again, if you can just simply recognize that the 3n squared and the negative 1n squared are going to combine together, there's no need to group them if you feel like you can keep that straight in your head. So some very straightforward, rather elementary, very straightforward problems, so that you can just get a little practice simplifying some basic algebra problems. So if we take a look at sample problem number 3, let's work part A, B, and C. So go ahead and pause the video at this time and then come back for the demonstration. Okay, so on part A, the very first thing we need to do is the distributive property twice. So we're going to start with 4 and distributing 4 to each part of the parentheses. So I'm going to have 4x plus 8. Then I'm going to distribute the entire negative 2, and that's going to give me negative 2x minus 4. Now here you can do as much detail as you feel comfortable with, or if you feel comfortable doing some of the work in your head, feel free to do that. But if you wanted to, you could either add the 4x and the negative 2x and just simply get 2x, or you could reorder everything to give yourself a better sense of what's going on. And so we're going to be left with 2x plus 4, and since 2x and 4 are not common terms, we can't combine those like terms. Okay, so that's a good start. For part B, we're dealing with j, which is kind of a difficult variable to see. But we need to really kind of group off the j's and separate the j's squared. So we're going to have negative 9j minus j. So negative 9 and negative 1 gives us negative 10j plus 7j squared. Now, if you stopped right here and left your answer like this, that's fine for the time being. Later on, when we get into polynomials, we will make sure that we put this in standard form, which would have the highest exponent first. And so that's a good habit to go ahead and get into. So our answer should be 7j squared minus 10j. So if we take a look at this last problem, again, we're going to have a couple of distributive properties to take care of. So we're going to start by distributing the 7. So I'm going to multiply 7 times x squared, and then times the negative 3. Then I'm going to distribute the negative 3 times x plus 4, so that's going to give me negative 3x minus 12. Now this is a situation where the x squared and the x are not like terms, so we just go ahead and write them in descending order of exponents. But the negative 21 and the negative 12 are like terms, so we can combine those to get negative 33. And so that is our simplified algebraic expression. Okay, so that is just a quick look at simplifying expressions. This should be a review for you from Algebra 1 and Pre-Algebra. And if you have any questions, be sure to ask your teacher.